In this video we're going to be going over gearing. So we're going to go over everything from the basics behind gear ratios, go through some examples, some math, and show you how changing your gear ratio might be beneficial for what you might want in your vehicle. So starting with the basics, so what is a gear ratio? So a gear ratio is simply a ratio between two different size gears. So the gear size changes by the number of teeth they have. So I've drawn it out here. You can see there's a gear with 6 teeth meshing with a gear with 9 teeth. So for every 3 full rotations of that 6-tooth gear, that 9-tooth gear is only going to rotate twice. So if you simply divide these numbers, you're going to get, it'll take 1.5 turns of the 6-tooth gear to turn the 9-tooth gear 1 turn. So your gear ratio is 1.5 to 1, also just simply referred to as 1.5. And so just below that again, if we had a gear with 4 teeth and a gear with 8 teeth, that would be a gear ratio of 2 to 1 or 2. So now I'm just going to list out some facts about a specific vehicle so we can use all of this information later when we actually do some calculations. So we're using a 2006 Jeep Wrangler TJ. So transmission is the NSG 370. It has 6 speeds, aka 6 gears. So first gear has the highest gear ratio of 4.46 to 1, all the way down to 6th gear, your overdrive with 0.84 to 1. Transfer case has 2 settings, a high and a low. The high ratio is just 1 to 1, and the low ratio is 2.72 to 1. And your front and rear differential, in this example, have a gear ratio of 3.73 to 1. Kind of a side note, not really related to the rest of the video, but in case anyone talks about crawl ratio, so that's kind of seeing the maximum gearing you can get out of your vehicle to see how much real torque you can put down. So that's going to be your first gear ratio times your low rating times the differential rating. So with mine, it's 45.249 to 1. Alright, but back on track. So why is gear ratio important? So if you take your engine torque and multiply the gear ratio, that's going to give you the output torque, or the torque you actually see at the wheels. So if you think about it, the engine has to rotate to move the wheels, and if you keep putting successively larger gears in the way of it rotating, the engine's going to end up turning more times for each revolution of the tire. So the engine turning more times means more strokes of the engine, more combustion, more power. So you're basically just using more power, really more fuel too, to get more torque and more power. So some rules of thumb that we're going to use later. So if you increase your gear ratio, your torque's going to go up, but your top speed's going to go down because that engine has to work harder to achieve the same speed. So your overall top speed is going to go down. And conversely, almost the exact opposite, if you increase your tire size, your torque's going to go down, but your top speed's going to go up. So we're going to look at why you may want to couple a change in gear ratio with a change in tire size for best results. Alright, next board. Alright, so we're going to get into the math here. So we're going to be using 3,000 RPM just as an example and calculate the top speed in each gear of the transmission at 3,000 RPMs. So our top speed is our engine RPM times our tire circumference divided by the gear ratio. So for me, I have 33-inch tires, so the circumference is going to be 33 inches times pi times the RPM that we're using, which is 3,000, times 60 minutes over hour. That's because we've got to convert the revolutions per minute we want to miles per hour. And then, so on the bottom we have the gear ratio. So we're doing first gear at first, so I have the gear ratio of 4.46, the differential ratio of 3.73, and we're assuming the transfer case is in high, so that's just a 1, so I didn't even write it in. So that gives us 1,121,172.41 inches per hour. We still got to convert a little bit to miles per hour, so we divide by 5,280 feet in a mile, 12 inches in a foot, and we end up with 17.69 miles per hour in first gear. So that's your top speed in first gear with this Jeep, with all the data that we laid out earlier. And I already did the calculations for second through 6th gears, and you can see 6th gear has a top speed of 93.95 miles per hour. Now it's important to note this is really more of a theoretical top speed because you're not taking into account the friction, the loss of power of the tires on the road, also the aerodynamics. So really these numbers are higher than they should be, but it's a useful tool to think about. So now, if you want to change your differential gearing, which is that 3.73, also known as your final drive ratio, your torque will increase accordingly. So it's just the percent change. So if I wanted to change mine from what I currently have, 3.73 to 4.88, which is another common differential gearing ratio, that torque change would just be the 4.88 minus 3.73 divided by 3.73, a 30.83% increase. But our top speeds would drop. So if we plug in 4.88 instead of 3.73 in this whole equation, we're going to get all new top speeds. So first goes down from 17.69 to 13.52. 6 drops from 93.95 to 71.81. And now this is really bad, because if we do that, as you see now, my top speed in 6th here is lower than even my top speed in 5th there. So I'm essentially losing a gear. Yeah, I'm getting more power in each of those gears, but some of these gears are almost useless now. So it's really not a good idea to gear too high unless you're going to also couple with change in tire size, which we're going to see in a second. Also, quick sidebar, so your RPMs are going to change too. So this is, again, as I said, more turns of the engine, more combustion, worse fuel economy. So just to show you, at 70 miles per hour, my car with the 3.7 gear ratio, the engine would be at 2,235.23 revolutions per minute, and with a 4.88 ratio, it would be at 2,924.34. Alright, so moving on. So we talked about coupling tire size with changing gears. So if I were to change my tire size from 33 inches to 37 inches, it will help preserve those top speeds from earlier. So our torque loss, as we said from the rule of thumb, the torque's going to go down, top speed's going to go up. So that's going to change accordingly. So the change from 37 to 33, it's going to be about a 12.12 repeating percent loss. Again, that's about, the real loss will be higher because with bigger tires you're going to have more weight, more friction, going to be harder to move. So really it'd be a larger number, but again, just for theoretical purposes. And our torque gain from before, this 30.83%, is just from assuming we're re-gearing, right? So it's the same number we got earlier when we're changing our differential ratio. So our overall change is just subtracting this number from this number is going to give us a 18.71% torque gain. So I would be gaining 18.71% torque if I up my tire size to 37 and up my differential gearing to 4.88. And so my top speeds wouldn't be exactly normal, but you could do the calculations. Again, just plug in all the same numbers here with 4.88 for the ratio and 37 inches for the tire diameter, and you can see, and it'll more or less preserve. It won't be as drastic of a change doing this. All these numbers will basically, or really all of these numbers, you could just multiply them all by 37 over 33, and you'd get the new ratio. One final note is that if you do either change your gearing or increase your tire size, your speedometer and your odometer are going to be off. So in this car, you can change that with a simple gear that's in the transfer case. Most cars, more modern cars, are probably going to be electronic, and you're probably going to need an OBD programmer. So yeah, but that pretty much sums it up. Let me know if you have any questions, and I'd be glad to answer them. Thanks.